The government of the region nitrogen has stated two objectives concerning the amount of nitrogen in the region. First, the atmospheric deposition should be reduced by 90%. Second, the leaching of nitrates should be reduced by 75%. The following model concerns the flows of nitrogen compounds for the region nitrogen, aiming at providing insight in the possibilities for using substance flow models in supporting environmental policy. This presentation gives advice on how the policy targets can be reached and how they should be adjusted. The boxes represent processes or groups or processes handling nitrogen compounds. The system contains both nodes that concern economic processes as well as nodes that concern the environment. The arrows represent the goods containing nitrogen flowing from one process to another. The first solution is the installation of a filter on stables in animal production. The region nitrogen has high rates of atmospheric deposition into natural soil. This happens because 10% of animal production deposits directly in atmospheric processes. This leads to a high amount of nitrogen deposition in natural soil. In order to reduce this amount of nitrogen, it is important to implement a filter which will not only take 5% of ammonia from animal production deposition, but will also reduce the amount of ammonia that goes directly to atmospheric processes by 5%. The filter will contain natural zeolite, a mineral often used as an ammonia absorber. Zeolite is a potent absorbent of water, gases, chemical compounds, metals, and odors. The second solution is increasing the recycling of waste treatment of compost and sewer sludge from 10% to 11%. Increasing more would only result in a negative effect on the entire system. Increasing recycling prevents or decreases the flow from a nitrogen sink to the accumulation of nitrogen in the atmosphere that may result in an increase of the leaching of nitrates. The third solution concerns the fertilizer production. Studies have shown that fertilizers are often applied in excess of crop needs. The excess nutrients are lost when nitrogen evaporates in the atmosphere in the form of ammonia, surface runoff, and leaching to groundwater. On average, about 20% of nitrogen fertilizer is lost through surface runoff or leaching into groundwater. According to University of Delaware Cooperative Extension, under some conditions, up to 60% of the nitrogen applied to crops can be lost to the atmosphere by volatilization. This is why the nitrogen region should implement MINUS policy for regulating nitrogen surpluses in agriculture. MINUS policy is being implemented in the Netherlands. This policy forces farmers to lower the input of nitrogen and phosphor via animal feed or animal manure, and to increase the nitrogen and phosphor use efficiency. As a result, the surpluses in agriculture are decreased. The uptake of nitrogen in crops and grass is increased by introduction of winter cover crop. This is the practice of planting crops in the off-season and later on processing them back into the soil. This reduces leaching by 50%. Furthermore, a study conducted in California coastal vegetable production showed that a winter cover crop of immersed rye reduced nitrate leaching by 70%. Carefully managed irrigation by splitting application of nitrogen fertilizer on long season crops and by injecting nitrogen instead of spraying. The fourth solution is about increasing the efficiency of uptake of nitrogen by plants. Recent scientific research done by CSIRO in Australia pointed out that wheat varieties that display early vigor have abundant root growth, increasing nitrogen uptake by 60 to 68% in the first 20 centimeters of the soil and up to twice as much in the layers of soil between 20 and 70 centimeters. The explanation for this is that plants have special bacteria on their roots that are able to fixate nitrogen, which is necessary for their growth. So an increase in root length results in an increase of those bacteria and therefore a reduction of atmospheric deposition. The final solution is the reduction of the import of fodder. Discontinuing the import of fodder is based on an existing theory that fodder import causes overnutrification in industrialized countries, while causing soil degradation in countries from where this fodder originates. Based on the fact that nitrogen is an industrialized country, it is important to include a policy that will restrict the import of fodder with higher taxes and that will also subsidize the production of fodder. This will contribute to minimizing nitrogen surplus. To accomplish the first objective, the original atmospheric deposition of 32.2 nitrogen should, after implementation policies, be less than 3.42. The filter maximizing recycling of waste streams in compost and the upgrade of nitrogen fixation due to GMOs will lead to 2.17 tons nitrogen annually, a reduction of 94%. The original leaching of nitrates is 285.5, and to meet the objective it should become less than 71.4. Upgrading the efficiency of nitrogen uptake by crops and grass and reproduction of fodder import results in 51.4 tons of nitrogen leaching annually, a reduction of 82%. What we have learned in this model is that in order to create sustainable solutions, we should not only implement a solution for a specific process, but we must take into account the whole system. Reconnecting what already exists, adding new technologies and policies are necessary. Hence, the influence processes have on each other, efficiency is enormous. A small change in the process should either lead to a devastation or prosperity of the system.